No, he doesn't. That is like
I do.
Okay, let's get started. So we're going to start with the homework. We're going to start with number 4. This one we're going to graph. So for this problem, we have f of x equals negative 1/3 times x minus 2 cubed minus 4. And to graph this problem, what I'm going to do first is I'm going to figure out, what's my HK point. And your HK point, it's like your change in concavity. And that's going to be 2, negative 4. And I'll put that right in the middle because your HK point is the middle of your graph. So I'm going to know what's happening on both sides of the graph. So after I graph 2, negative 4, what I'm going to do is pick 2 points to the left of x and 2 points to the right of it. And because I have a b value of negative 1/3, I'm going to increase and decrease by 3. And that's because I don't want to deal with fractions. So if I increase and decrease by that denominator, I won't deal with fractions. So I can go to 5 and 8, and I can decrease to negative 1 and negative 4. So when I increase and decrease by that denominator of b, or 1 over b, that means I won't deal with fractions. I can plug it in. I'll get nice numbers to graph. So when I plug in negative 1, I'm just going to kind of do it all in my head. When you put in negative 1, you get negative 1 minus 2, which is negative 3. Negative 3 times negative 1/3 is a positive 1. 1 cubed is 1 minus 4 is negative 3. So when x is negative 1, you get negative 3. When x is negative 4, you have negative 4 minus 2, which is negative 6. Negative 6 times negative 1/3 is a positive 2. 2 cubed is 8. 8 minus 4 is 4. And then for 5, you plug 5 in. 5 minus 2 is 3. 3 times negative 1/3 is negative 1. Negative 1 cubed is still negative 1. Negative 1 minus 4 is negative 5. And then with 8, 8 minus 2 is 6. 6 times negative 1/3 is negative 2. Negative 2 cubed is negative 8. Minus 4 is negative 12. So I have 2, negative 4. I have 5, negative 5. 8, negative 12 is way over here somewhere. Yeah, I'm about to go turn it up. Then negative 1, negative 3. Then negative 4, 4. You get a function that looks like that. Any questions about that? It's pretty basic, just graph it. And then from here, you can figure out pretty much anything you need to do. X-intercept, Y-intercept, and behaviors. Get something here. You can ask, when am I decreasing? I'm always decreasing. And you can pretty much figure out anything else you need from there. All right, let's go on to the next one. All right, so number 5 on the homework. I want to find the cubic function g of x. If g of x equals 2/3 f of 3 times x minus 5 plus 7, and f of x is 12 times x plus 6 cubed minus 45. So for this one, I want to see, what is g of x going to equal if g of x is these transformations on f of x. So what this tells me is that g of x, or really to get g of x, I have an a value of 2/3. You have to apply that onto f of x. So what I'm going to do is I'm going to apply these one at a time. So when a is 2/3, and I apply that to f of x, what I'm going to get when I multiply it over there is that 12 times 2/3. And then I have that parentheses of 2 x plus 6 cubed minus 45. And that a is also going to apply to that 45. So what you get, 12 times 2/3 is going to be 8. Then you have 2 x plus 6 cubed minus 30. So that takes care of this 2/3 right here. After that, add that b value. Well, it's really a 1/b value of 3, but really a b value of 1/3. Right, so that 3 is my 1/b. So I'm going to apply that 1/b into that function. So what I'm going to do now is I have 8 times 2. Then I'll put in that 3 right next to the x. So that's where you always want to put your 1/b term. So I'll put my 1/b term directly with the x. And now I'm going to factor it out to get 6x plus 2 cubed minus 30. Everyone with me so far? Are we okay? And that takes care of this 3 inside that g of x. And the last thing I have is an h value of 5 and a k value of 7. And I'll apply that as well to the last formula that I have. Is 8 times 6 times x plus 2 all cubed minus 30. So when h is 5, how I kind of think about it is that I have an h value of -2 currently for that x plus 2. Right, this x plus 2 tells me I have an h value of -2, but I'm going to add I'm going to add 5 to it. So that means my new h value has to be a positive 3. Right, so I have a -2. So x plus 2 tells me h is -2. But I'm increasing that -2 by 5. So my new h value needs to be 3. So you plug that in, you get x minus 3 cubed. And then I'm going to add 7 to that -30 to get -20. And that's what g of x is. That's what they tell me in the formula. So it tells me 1/b is 3. Right, that 3 inside that thing. I know this escape thing, I don't know how to get rid of it. But it's in the way, but that 3 in there in the problem, that's what your 1/b is. Any questions about that? Are you okay with that? All right. Keep going then. Number 7, this is a problem we emailed you, we told you guys to go over. I'm only going to go over 7a for this one, but that's pretty much the hard part of the problem. Y'all can go over 7b on your own. So for this one, we need to use complete sentences to describe the transformations that take the graph of f of x to g of x. So what I want to do is I want to see how do I go from this function, from f of x to g of x. And to do that, you need to do everything in an order. You have to do a and b first, and then you can go on to h and k. And every time you do a transformation, you have to apply it to that function to see where you're going. So the first thing I'm going to look at is I'm going to look at the 6, and I'm going to look at the 4. Where I'm going to see, well, I have a 6, but I want to transform that 6 into a 4. So how do you do that? Well, you can multiply it. You can multiply your f of x by 2/3, exactly. So I can multiply f of x by an a value 2/3. And when you do that, f of x will be 6 multiplied by 2/3 of 2x minus 3 cubed minus 18. And don't forget that 2/3 also affects the 18. So when you apply a 2/3 onto f of x, what you get is 4 times 2 of x minus 3 cubed, was that minus 12. So the big thing here is that when you change your 6 into a 4, that's also going to affect your k. So my -18 becomes a -12. So after that, I dealt with a 6. Now I want to see, well, I currently have a 2 right here for b. But if I look back into what I want that to be a -1. Right? So where I'm currently at, that's the one you always need to look at. I'm currently at a 1 over b value of 2, but what I want is a 1 over b value of negative 1.
It is now 3 o'clock. If you are not with a coach, director, sponsor, or in tutorials with a teacher, you must now exit the building.
So what this means is that I have a b value, 1 over b of 2, I want a negative 1. I need to put in a negative 1/2 into the formula that I currently have to make it into a negative 1. So what that means is that I want my 1 over b value, because remember, that's what you put into the formula. I want to put in 1 over b into the formula. I want that to be negative 1/2. Because when you put in that negative 1/2 into the formula, what you get is 4 times 2. You always plug in your negative 1, your 1 over b right with the x.
If you put in negative 2, not 1 over. If it's 1 over b, you try to put in 1/2.
Yeah. So I think you're thinking b. The b is negative 2. That's true. The b is negative 2. But I think of it more as, what do I need to put into this formula, into this one right here? What do I have to put into there to make this 2 into a negative 1? That's what I want.
You're multiplying that.
Yes, you're multiplying out. So I don't like to think of it, oh, b is negative 2, so I have to put in a negative 1/2, because it gets kind of confusing kind of going between b and 1 over b. So that's kind of think of it as, what do I put in? And what you put in is 1 over b. So I have to put in a negative 1/2, this green one right here. I have to put in a negative 1/2 into here. Because when you do, when I factor out that negative 1/2, that 2 becomes the negative 1 that I want. That makes sense?
Yeah.
So the 1 over b value is negative 1/2.
Yeah.
So when I factor out that negative 1/2, I get 4 times that negative that I want of x plus 6 cubed minus 12. Right? Because when you factor out a negative 1/2 out of negative 3, well, negative 1/2 goes into negative 3, positive 6 times. So you factor that, that's what I'm at right now. Any questions about that? So I know the b is probably the confusing part here. All right, so my 1 over b is negative 1/2. After that, I have to see where I'm at, and I have to see, what do I want? So where I'm at is that I have a b value, or sorry, an h value of negative 6. But what I want is negative 1. Right, so the way I think about it, like I said before, is, well, I'm at an h value of negative 6. How do I go from an h value of negative 6 to an h value of negative 1? Well, to go from negative 6 to negative 1, you have to add 5. So that tells me that h has to equal 5. Right? Because what I'm at, this purple highlighted part right here in the bottom, that tells me x plus 6. That tells me h is negative 6. But if I look at what I want an h value of negative 1. So you go from negative 6 to negative 1. I have to add 5, or I have to have an h value of 5. And then when I look at my k value, I have a k value of negative 12. That's where I'm currently at. But what I want is a k value of negative 5. So how to go from negative 12 to negative 5? Well, I'm going to add, that's 7, right? 7. So I also have to add 7 to that function. So when I apply both of these into my formula, you get what you want. And these green parts are the transformations that you're doing. I don't feel like writing it out, to be honest with you. So I'm just going to say it out loud. So A is 2/3. What that means is you have a vertical compression of 2/3. That 1 over b part tells me I have a, we'll be right out actually what it actually is. So 1/2, 1 over b equals negative 1/2. That tells me b is negative 2. So that tells me I have a vertical stretch by negative 2 and also a reflection over y. And then h and k, h tells me I have a shift 5 by 5, and k tells me I have a shift up by 7. Everyone okay with that? For 7b, I'll let you guys do it on your own. I'll make sure you know how to do it for the quiz tomorrow. But remember, all it's going to be, in this case, g of x equals a f of 1 over b, x minus h, all plus k. Just plug in your formula into here, and that's what you should get. I'll let you guys do that on your own. The answer key is online anyway, so you should be able to double check that. Any question about that? Go ahead. When you factor something out, you're dividing by what you factor out. So this negative 1/2, when I factor that out, what you're essentially doing is saying, well, I'm going to multiply negative 1/2 on the outside and divide it by the inside. This is essentially what you're doing when you're factoring something out. So I'm multiplying the outside by negative 1/2, but inside I multiply by negative 1/2. So when you divide by -1/2 inside, the -1/2 divided by -1/2 is 1. -3 divided by -1/2 is +6. Are we good? Great. All right, so I have a table problem. Y'all are my students, but I didn't show this to you guys in class, but I'll take a picture of this and how to do it. This is a new problem that I'm going to show you guys how to do. So I didn't show this to you in class. It's an extra problem. It's not in your homework or anything like that. So either take a picture of it or write it down, whatever you want. You got it? All right. So I want to write the equation of this cubic function f of x that's represented by this table. So we talked about this before. And actually, we're going to make this a little harder because I think it's a little too easy for us to see. We're going to completely scratch out this point right here. So we're going to pretend this point right here doesn't exist, okay? Just because I want to make sure it's not too easy, because the reason I'm doing that is to kind of show you. Remember I told you guys, when you want to solve out these table problems, the first thing you should do is kind of look at your y's and see where your y's kind of congested together. Because when you have your cubic function, you have those 3 points right in the middle that are, really close to each other, right? And in this case, you can see that these 3 points right here are all right next to each other. And your HK is always the one right in the middle. So you can look at this right away and see, well, that's definitely my HK, right? So that's why I want to make this a little harder, just because it'll reflect more of what you'll see on the quiz. So cross out the -6.25, and we're going to look at it like this table right here. So from here, we're going to do the same thing. I'm going to look at this table and see where are my y's kind of close to each other. And my y's are pretty close to each other between these two points right there. All right. So once you know your y's are really close to each other, it kind of narrows down where your HK is going to be. All right, so from here, once I figured out my y's are kind of close together, I'll isolate those points, and then I need to figure out, well, which one of these is going to be my y value, or my HK, sorry. So to do that, what I like to do is I like to kind of see, well, where do I have equal jumps kind of going out? Remember, your HK point is the point right in the middle of the whole parabola, right? Look at this diagram right here. Your HK is the one right in the middle. So you should have equal jumps going out. So if I look at the -4 first, which we already know it's now giving me the point, the HK point. If I look at it, if I see, well, if I go from -4 to -3, that's a difference of 1. And then from -5.7 to -4, that's a 1.75? Positive 1.75, right? Right? So if I go 1 to the right, I have that different. If I go 1 to the right with x's, I have a y difference of 1.75. So if I go 1 to the left, I should have the same y value, right? But from -5.75 to -6, that's -0.25. It's not the same. That tells me that -4, -5.75, that's not the middle of the whole graph. So that means that cannot be my HK point. So I'm going to go ahead and try -5, -6 instead. I'm going to see, well, is that actually in the middle? So look at -5, -6. If I jump 2 to the left to -7, I have a difference of, what's that, -2. And then if I jump 2 to the right, you have equal jumps both ways. When I go 2 to the right, I have a difference of +2 as well. So I have the same jumps going outward. And if this table is any bigger, you'll see that if I have an x difference of a 3 or 4 or 6 or whatever it is, you'll see that it's the same thing. It's equal jumps going out both ways. So that's how I know that my HK point is -5 comma -6. Does that make sense? Are you okay with that? Great. So that's HK. So from here, there's two ways to solve for A. I guess like the easier way to see it is that you can just plug this into your formula. Say f of x is A times x plus 5 cubed minus 6. Then plug in whatever point you want into the formula, and then just solve for A. That's one way you can always do it, and it'll always work. So I'll go with, I don't know, -3, -4. So -4 equals A, -3 plus 5 cubed minus 6. I plug in the point -3, -4, and I'll solve this for A. So add the 6 over, you get 2. That equals A times 2 cubed, or 2 equals 8A, or A is 1/4. And then you just plug this right back in, and get that the equation for this problem is 1/4 x plus 5 cubed minus 6. Any questions about that? So that way it will always work. You always plug in a point, solve for A. The other way is that when you jump by x value 2, your y should also jump by the cube of how much you jumped your x by. So if you jump by 2 for x's, your y's need to jump by 2 cubed or 8. If your x jump by, in this case, 6, your y's need to jump by, what's that 6? That's 4. By 4, your y's need to jump by 4 cubed, whatever that might be, 64, right? But in both these cases, it's not 64. Instead, it's 14. So what's happening is that, well, I jump by 2, so it should be 8, right? From -5 to -3 is a jump of 2. So my A jump should be 8, but I compressed it by some A value and got a jump of 2 instead. So you solve for 8, or for A, sorry, you get 2 over 8, or that's the same one. It's a different way to go about it. It doesn't matter which way you do, you'll get the right answer either. Any questions about either of those? Are we okay? Yes. Well, horizontal compression will always have it's always related to a vertical compression. So if we give you a horizontal compression, which, I mean, we're not going to do that anyway, you can just solve for a vertical compression, you get the right answer. We won't ask for that. Any other questions? Are we okay? All right. So now we're number 13. We're back on the homework. So number 13, name the following by degree and number of terms. Also state the end behavior for each of these. So number 13, I have x to the 9th minus 5x squared plus 10. Well, I have 3 terms, and the term with the highest degree is x to the 9th. So that's what you call your leading term. And your leading term tells you both your leading coefficient and also the degree of the whole polynomial. So this is a 9th degree polynomial. It says I have 3 terms. We'll call that a trinomial. So make sure you look at your chart that you have in your notes that kind of tells you how you call every degree and the number of terms. And then we need to state the end behavior for each of these. So for this one right here, I have a 9th degree polynomial. So I have an odd degree polynomial. And the leading coefficient of the whole polynomial comes from the leading term, which is x to the 9th. So the leading coefficient is 1, or in other words, it's positive. So it's an odd degree polynomial that has a positive leading coefficient. So I should have end behavior similar to y equals x or y equals x cubed. It's the same thing. Right? They're the same end behaviors because they're both odd degree functions with a positive leading coefficient. So this means as x goes to infinity, y is going to infinity. When x is going to infinity, negative infinity, y goes to negative infinity as well.
But I thought the degree was where you added up all the.
That's if everything being multiplied together, right? Because when what a term is everything being multiplied into one term. So that's why 5x squared is negative 5x squared is one term, because a negative 5 and x squared is being multiplied together. But individual terms are stuff being added together. So that's why this polynomial, x to the 9th is one term, negative 5x squared is one term, and plus 10 is one term. But they give you something like x minus 3 squared times x plus 7 times x minus 3, doesn't really matter, x minus 3 cubed, why not? This is all considered one term because everything's being multiplied together. So that's why in this case you have to add up all the degrees to see what all the exponents to get your degree. Because this is considered one term, right? This way here is considered one term, while this problem is considered 3 individual terms. Does that make sense? Any other questions? Are we okay? Great. So now it's some graphing. So number 19, y equals negative x times x minus 2 cubed times x plus 1. So this one, there's no factoring in it. So all we need to do is label out my x-intercepts. So in this case, I have an x-intercept at 0 from this negative x. An x-intercept at negative 1 because it's x plus 1. And an x-intercept at 2 because of x minus 2. So once I label out my x-intercept and also my y-intercept, but in this case, since I have an x-intercept of 0, that's also my y-intercept. So I don't need to solve for that. My leading coefficient in this problem is negative 1, right? So the term, the constant right in the front. So my leading coefficient is negative 1. My degree in this case is going to be 5 because this is all considered one term, so you have to add up all the exponents. So 3 plus 1 is 5. So the degree of the whole thing is 5. So what that tells me is I have a negative leading coefficient with an odd degree polynomial. So it should have end behavior similar to y equals negative x or negative x cubed. The same thing. So that means I should start from the top and I should end going down. So I should start from the top and I should end going down. And all I'm going to do now is figure out, well, how do I act at each of those x-intercepts? Right? So if I start from the top and I go to negative 1, well, if I look at my function, or sorry, my polynomial, that's a degree of 1. So if you have a degree of 1, or the factor has a degree of 1, you go straight through that point. At 0, that also has a degree of 1, so we go straight through that point as well. And at x minus 2 cubed, that's a degree of 3, so that's where you have that concavity change and it kind of curve into it and curve back down. So you curve it to be perfect, just kind of make it look like you try to curve somewhere, somehow, and it's fine. So that's going to be how that function looks. Does that make sense? Any questions about that? Good. So 0 comes from this negative x right here. So anytime you have an x, remember x is the same thing as saying like x minus 0, right? Same exact thing. So just saying you have a y-intercept or x-intercept at 0. I'll take care of it. Thank you. Any other questions about that? Are we good? All right. So end behavior. If I look at this function, I can see that when x goes to infinity, f of x is going to negative infinity. And as x goes to negative infinity, f of x is going to infinity. All right, let's keep going. Yes. One of those. I don't plan on doing one of those, but I would do one of that. It's fine. All right. Example 25. I have negative 3x cubed minus 18x squared minus 27x. So I can't really graph it how it is now. So that means I have to factor it first and put it into my factored form to be able to actually graph it. So anytime you're graphing or you're factoring something, the first thing you should always look for is a GCF. So if I look at this polynomial right here, I have a GCF of negative 3x. So you factor out that negative 3x, what you're left with is x squared plus 6x plus 9. And then x squared plus 6x plus 9, That's a perfect square trinomial. So that's going to factor out to x plus 3 squared. Everyone with me? Are we okay with that? All right, so that's your factored form for this y. So when you want to graph it, I have y-intercepts at -3, or sorry, x-intercept at -3, but then x plus 3, and x-intercept at 0 because of that x. I'm sorry? The origin? Yes, because -3 is just a coefficient. Because you can really rewrite this as -3 parentheses x minus 0 x plus 3 squared. It's the same exact thing. It's just that saying x minus 0 is kind of redundant, right? Then maybe just say x. So from here, I'm gonna see what my leading coefficient and what my degree is, just so I can figure out my end behaviors. My leading coefficient is this -3, and my degree, if I add everything up, is 3. And you can also just look at your leading term from the very beginning. A leading coefficient of -3 and a degree of 3. So that tells me I have an odd degree polynomial with a negative leading coefficient. So I should have end behavior similar to y equals -x. Just like that. So it should start from the top, and I should end going down. It should start here and end going down this way. And if I look at x plus 3, so I need to see how am I going to react at that x-intercept. At x plus 3, that is a exponent of 2. So every even exponent, you bounce off of it. So when I get to -3, I'm going to bounce off of it. And when you get to 0, that is a degree of 1. So that tells me I have to go straight through that point. And that's how you graph your function. Does that make sense? Any questions about that? All right, so if I look at my end behavior, as x goes to infinity, f of x is going to -infinity. And as x goes to -infinity, f of x is going to infinity. Right, the same end behaviors as y equals -x. Right, they're both odd degree functions that have a negative leading coefficient, because y equals -x is raised to the first power, 1 is still odd. All right, let's keep going. All right, so now we're on problem 30. Write the equation of a polynomial function of a degree of 4 that has 2 roots at -4 and 2, and y-intercept at 0, -32, and it has a maximum value of 0. So anytime you have problems similar to this, you always want to draw a picture. If you don't draw a picture, you're not going to get it right. It's going to be kind of hard to kind of see or kind of visualize what's actually happening. So always draw a picture. I'm told I have x-intercept at -4 and +2. And I also have a y-intercept at -32. So I'm going to go ahead and plot these points. So the other key piece of information that I'm given is that the graph has a maximum value of 0. What that means is that my y value cannot be bigger than 0. So that means I'm below or at the x-intercept. Right? So I cannot be above the x-intercept. I can go right up to it. That's kind of how you get x-intercepts. So what that tells me is that I have to start from the bottom, because if I don't, there's no way I can actually, I can't meet that criteria, right? I have to start from the bottom. So when I do that, when I get to -4, that means I have to bounce off of that -4. First to get to that -32, but second to make sure I don't go above that x-axis. And then when I get to that +2, I'm going to touch that and bounce back off that as well. That's what your graph should look like. Right, you start from the bottom, you have to bounce off both those points, because if you don't, you have a y value greater than 0. And since I'm told I have to have a degree of 4, that makes this problem pretty easy because I can just distribute that 4 into 2 and 2. Both these x-intercepts are bouncing off those points, right? The graph is bouncing off both those x-intercepts. So that means they have to have an even degree, because only even degrees bounce at the x-intercept. In this case, the only way I can distribute 4 into 2 even numbers is 2 and 2. So what that tells me is that f of x is going to equal some a term times x plus 4 squared and x minus 2 squared. Is everyone with me so far? Are we okay? All right, and then I need to figure out my leading coefficient is going to be. And I can get that by plugging in the point they gave me of 0, negative 32. So I have negative 32. That equals a. 0 plus 4 is 4, all squared. 0 minus 2 is negative 2 squared. So negative 32 is a times 16 times 4. I can divide the 16 over to get negative 2 is 4a, or that a is negative 1 half. Are we good with that? So you plug this back in, you get that f of x is negative 1 half, x plus 4 squared, x minus 2 squared. And that's your answer. Are we ready to keep going? All right, the last problem. Problem 34. So I'm told if f of negative 7 equals f of 4, which equals f of 2, which equals f of 1, which all equals 0, and that f of 3 equals negative 10, and f of x is a polynomial of degree 4, find f of 0. So this whole part right here, what that's telling me is it's just telling my x-intercepts. It's just telling me that I have points negative 7, 0, 4, 0, 2, 0, and 1. So when I put that into my formula, I know that my f of x is going to equal some leading coefficient that I don't know. Negative 7, 0 gives me the factor x plus 7. 4, 0 gives me the factor x minus 4. 2, 0 gives me the factor x minus 2. 1, 0 gives me the factor x minus 4. And the reason why I didn't draw a picture here is because I didn't really need to, because I'm given 4 x-intercepts, and I'm also told I have a degree of 4. So the only possible way to distribute 4 exponents, like a degree of 4 or 4 exponents into 4 x-intercepts, is that they all get a power of 1. There's no other way to distribute it, so I know for sure this is what it has to be, and that's why I didn't draw a picture, because it'll be kind of unnecessary in this problem. And then from here, I'm also given to have a point of 310. Right, I'm told I have a point 310, so all I need to do is plug in that 310 into the formula and solve for it. So 3 plus 7 is 10, 3 minus 4 is negative 1, 3 minus 2 is 1, and 3 minus 1 is 2. So these 10s cancel out. You're left with 1 equals, that's a times negative 2, or a is negative 1 half. So plug that a back in. You get that f of x is negative 1 half, x plus 7, x minus 4, x minus 2, and x minus 1. Any questions about that? Are we good? All right, so you want to go over that one problem, easy, one of those problems? What do you want to do? Easy.
I didn't know. Okay.
So for this problem, what we want to do is we want to figure out the equation of this problem. So in the instructions, it wasn't really clear, but it was meant to say you want to put in the smallest possible degree that you need. So for instance, if I look at this problem here, I have x-intercepts at 0 and at 3. So if I was to write out my polynomial function here, well, p of x equals some a, that 0 gives me just an x value, an intercept of x, and that 3 gives me an intercept of x minus 3. And then I need to figure out what other exponent is going to be. At 0, I see that kind of curve in and curve back out. So I'm going to raise that the factor that the 0 gives to a third. And then if I look at the x-intercept of 3, I bounce off it. So I'm going to give it an exponent of 2.
You technically don't need any exponent.
Well, see how it kind of curves in, curves out, has a concavity change? Okay. That's why you have to assume it's 3. And the reason I'm using 3 and not like 5 or 7 or 9 or some other odd number is because we want to use the smallest possible exponent that we can. And same thing with the x-intercept of 3. I'm going to use the smallest possible 1, so I'm going to use 2 instead of 4, 6, or 8. And then just plug in the point 112. So 12 equals a, 1 cubed, 1 minus 3 squared. Or 12 equals, that's what, 4a, a is 3. So plug it in. Your polynomial is 3 x cubed, x minus 3 squared. Are we good with that? What time is it? 3:32. Do you have any other problems you want me to do before y'all head out? Before I end the recording, any problems you want me to go over? This is saying that g of x is this transformation on x. I don't have the g of x form for something. It's saying a is 2/3, and you divide 2/3 into x. You vertically compress it by 2/3. You apply those transformations. If I go back to number 5. This one right here, right? Essentially what it's saying, Dennis, look at it. I'm doing it in blue. What is the problem saying is that I have an a value of 2/3, right? I have an a of 2/3. I have a b of 1/3, an h of 5, and a k of 7. That's pretty much what it says, right?
And you apply it.
Yeah, exactly. So g of x is these transformations on f of x. So you apply each one onto f of x, and that gives you your g of x. So you kind of do it one at a time. You do a first, then the b, then the h.
It's easy.
It's easy. You have to see which one's the leading term. So this one, the leading term is negative 3x to the 8th. That's the one with the term with the biggest degree. So it's not in order, but the one that's like the leading term is always the one with the term with the highest degree. So that's why the leading coefficient is negative. It's easy. Have a nice day. All right, guys. Any questions you want me to go over before I end the tutorial? No. Great.